first up, we'd like to invite Ms. Marcy Merksamer and Mr. Kevin Reynolds, who are the co-chairs of the Ballast Water Expert Group. They're going to kick off our next session with a presentation on contingencies in ballast water management to effectively control the spread of marine invasive species. Thank you.
Great, thank you for the introduction. I'll start by saying that I am a self-proclaimed ballast water geek, and my family calls me that as well, so that'll preface a little bit of what I'm going to say. After 15 long years of waiting for the Ballast Water Management Convention to enter into force, we have finally arrived at the stage that I have been waiting for. And that's implementation. That's the whole point of what we're trying to do, is not just talk about it and develop the regulation, but actually now implement it. We have scientific evidence that the risks of aquatic invasions have continued while the world has taken the time needed to reach enough common ground to ratify the convention. During this time, unfortunately, ballast water has largely gone unmanaged. The slides you're looking at here are some of the worst invasive species that have caused some of the largest problems around the globe. We also have enough science evidence to suggest that other environmental issues facing our oceans, such as climate change, can work synergistically and detrimentally to facilitate the introduction of aquatic invasive species. So as a ballast geek, I am most excited for the implementation phase of the ballast water journey because our oceans simply can't wait any longer. We are now going into the experience building phase designated by the IMO for the purposes of collecting data and learning lessons about implementation of ballast water regulations through 2022. It is roughly estimated that approximately 50,000 vessels will need to fit ballast water management systems and be expected to meet the ballast water performance discharge standards around the globe. The experience building phase has been designed as a non-penalization period where ship operators, technology providers, and port state control gain experience on the practical operation of complex new equipment, machinery, operational procedures, and implement the new regulatory requirements. But implementation won't be easy, and it won't be perfect. In fact, it's my opinion that it's likely to get pretty messy. All stakeholders will encounter new and unexpected and even difficult situations. Already, we have learned that turbid waters can overwhelm UV system light transmittance. Silt can almost instantly clog filters of the ballast water management systems, and user error can override safeties that can result in catastrophic events like explosions. We have learned that in some instances, electrolytic chlorine generators may not treat to their highest level of performance when they arrive in low salinity ports. And we have also learned that the commissioning, sampling, inspections, and verification of proper system functioning is challenging. Port state control, they might struggle with development of their compliance processes, and ship owners and crew members are going to face challenges in knowing how to prepare for those port state control inspections that might differ in differing areas. So how we handle these new situations, hopefully as opportunities for innovation and to find practical solutions. There are many areas for us to focus on, as I mentioned earlier, sampling, looking at how systems are functioning properly, and just implementing this new equipment. And one such area that the Ballast Water Management SIG has been focusing on is contingency measures. And it's our belief that this is going to be a very important aspect of the implementation. And what is a contingency measure? It's what can a vessel crew member, a system manufacturer, a port state control officer, what can they do when they encounter a situation of improperly managed ballast water? In many cases, they can rely on contingency measures, which may be needed for some of the reasons mentioned above. a ballast water system overwhelmed by local water conditions, or a system that malfunctions unexpectedly. Maybe a vessel encounters emergency situation or is rerouted, leaving insufficient time for ballast water management. Until recently, the concept of contingency measures has been viewed primarily from a policy and a reactionary perspective. That is, contingency measures have been viewed as ways to handle non-compliant ballast water after a vessel has arrived in port. Utilizing our expertise and experience with onboard ballast water treatment, we, as the co-chairs of the Ballast Water Management SIG, have worked to add another perspective to this view. We ask what can be done proactively to address the various scenarios a vessel may encounter before its arrival in port with potentially non-compliant ballast water. Proactive solutions not only make good sense, but they also align with the views of industry stakeholders who would much prefer to avoid the operational and commercial implications that potential non-compliance with ballast water regulations can create.
It's pretty fantastic to be part of a SIG where it does embody the whole IMRS aspect, right? We have marine engineers, folks who've sailed on ships. We have scientists, marine biologists, technologists who develop the equipment. And as we meet and as we talk about this, we're able to get a broad perspective that we think can make an impact on the industry. In this case of contingency measures, we're trying to understand, we're trying to have a kit continue to operate. And so the marine engineer is like, okay, things need to function, green lights need to be on, I need a procedure. The marine biologist is thinking, if things go wrong, well, can't we do something to at least partially treat the water? Because we're trying to protect the environment, that's the point. Kill the organisms in the water so they're not transported. So as we then look at the regulations, we're participating in Marine Environmental Protection Committee at IMO, and we're watching the regulations roll out. We say this lens enables us to identify gaps, and this contingency measures is one of the gaps. In fact, the IMO convention until MEPC 73 didn't have the word contingency in it. There was always an assumption that you install the kit, you put a manual on board, and everything's going to go great. And I don't know, any mariners in the room here? Do things always go great? Yeah. Yeah. So we stepped back, and contingencies got introduced eventually through IMRS, putting in papers over the last 3-4 years, not in the convention yet, and it became part of the dialogue, part of the discussion. And from there, it got determined really to be a port state control issue. And we saw that as a good step to actually be considering what happens when a ship shows up with non-compliant ballast water. Your options are pretty horrible. Sorry, you can't do cargo operations, go away, right? That's one option. The other option is, well, try better next time and discharge your aquatic invasive species into our harbor. So pretty lousy options. Quite recently, IMRS, through the Ballast Water SIG, submitted a paper trying to change this thinking. And it's not so much that this particular topic is so important to the group here. It's really just how IMRS works and how we can take all these perspectives and make a real impact on how the world does its shipping. So we said, no, there's things you can do immediately. There's things you can do as alternatives, and then there's things you can do once you arrive in the port. So I'll touch on each one of those to give that perspective. So immediate, if you're running a treatment system and the filters become overwhelmed, what sort of planning can be put in place from the ship operator, from the manufacturer, to identify the filter's overwhelmed. And then what in the world do? If you don't do this planning, the filter gets overwhelmed, you shut down the system, you load non-compliant ballast water, and you're in a world of problems. Don't do that. Instead, it sounds very simple, and it is, but until you implement this, it doesn't happen. Instead, identify what are the parameters that you need to monitor, and then identify a plan on when you see that differential pressure across the filter rise to a certain point, what is the corrective action? Tell the operator you can shut down the ballast water and then fix the problem, and then keep the cargo operations and the ballasting going so that you don't take on non-compliant ballast water. What are the repair kits? There's not a lot of discussion on what spares should be on board and how to implement those spares and when to utilize those spares. One sensor could fail, rendering the system unusable. If you don't have that spare sensor on board and you haven't instructed very clearly how to change out that sensor, you're not going to be up and running, and you're taking non-compliant ballast water, which is bad for operations, bad for charterers, and bad for the environment. A very simple amount of pre-work allows you to then identify what's wrong and then fix the problem and be back up and running. So from the IMRS perspective, this is sensible, and it should be promoted in the actual convention and in the regulations. The second is alternative. There's all sorts of discussions and work being done on alternative measures. However, there's not a lot of preparation for them. For example, ballast water exchange, it continues to be promoted as an alternative measure. If you're in a freshwater port and you're running an electrolytic system to make chlorine for treating the water, that electrolytic system probably doesn't operate well. So then what do? And what's been promoted is go out to sea and conduct an exchange. However, if you're now conducting an exchange with chlorinated water, this chlorinated water is overflowing on the deck and exposing crew to that chlorinated water. I don't necessarily know if that's a good idea. It needs to be evaluated. It needs to be considered. So we're saying this is possibly a good contingency measure if you weren't able to get the kit up and running immediately while in port. Maybe this is a good way to go, but it needs to be very carefully considered. Our ballast water exchange has been a risky operation in terms of hull stress and vessel stability issues, and now at the last minute as a contingency we're going to do ballast water exchange, and the answer is you have to plan for it and you have to carefully consider it before taking on this sort of measure. Another contingency, another alternative would be if you a lot of systems have filters and a disinfection unit. If the filter is overwhelmed, can you safely continue to run the disinfection unit for some partial treatment? It makes sense to me, but I think it's important that it's required conversation between the manufacturer and the ship operator on how to handle this. Port-based. If you get into the port and you hadn't been able to take care of something immediately, you weren't able to conduct any alternatives, now what do? There's groups that have worked. Damen has actually put together their treatment system that's portable. You could put it on a dock and you can pass the ballast water to them. But how many ships are actually ready for that? How will they transfer that water? Do you want to organize this at the last minute based on some sort of emergency? Just last week, we had a vessel came into New York, and it had 5,000 tons of ballast water. We spent quite a lot of time trying to find a barge to offload the ballast water to the barge. That was very difficult. Ourselves, we're working on a mobile treatment system in the picture there where people can come on board and treat the water. But where is the planning for this? So these port-based measures are a third level of contingency, but it needs to be planned. Through our SIG, we were able to submit documentation through MEPC, at MEPC 73, in the guidelines for ballast water management plans for the first time put in the word contingency, and contingency measures are now allowed to be part of the ballast water management plans, which we see as something that is in a positive direction. So this is one example where the biologist, the technologist, and the engineers can get together, identify an issue, put together a framework, and make a real difference in the daily operations of vessels for protecting the environment and having practical operations.
So in summary, essentially, we just wanted to share that our SIG has been very active in the discussion of the Ballast Water Convention over the last 15 years at the IMO level. And we view our role very much as how do we support ensuring that the technology is in fact doing its job of treating ballast water and protecting a sustainable marine environment. Also, how can we help ensure that mariners have usable technology, reasonable and practical means of achieving compliance, as well as the ability to safely perform their work of moving the world's goods around the globe. As Kevin mentioned, our SIG has introduced and supported information and action papers at the IMO, and he discussed one of our recent successes of being able to get contingency measures actually included in one of the guidelines, which we felt was really important, because if it's not in there, how can you prepare? And having that advanced planning is really critical for them to have success. We know that as implementation starts, there will be challenges. So if we can support and spread the mission of preparing for those eventualities, that's really one of the important things that needs to happen. Overall, we believe in the blue economy, and we believe that environmentally sound and sustainable practices can be practical and can support our world's commerce. Our SIG has played, again, an active role in the convention and its adoption, and now as we move into the implementation phase. We'll continue to support practical, safe, and effective implementation. It's the major investment of the IMREST, as well as all of the experts that work with us in our SIG. Thank you very much for your attention, and we look forward to questions.
Kevin, Marcy, thank you very much indeed. Just to comment, this is one of the SIGs I've seen that has done so much work, in particular at the IMO, at every single stage of the convention, and it really is terrific.
Thanks.
The outputs and the success that you've had, so it's really great. And Bev, if I could pass you over for questions, please.
The first question, I'm going to look at Tom because he may be answering this in the following question, but may not. And the question is, treating ballast is great. Thumbs up. But what about invasive species carried in sea inlet boxes, thruster tunnels, etc.?
You want to take that one?
There we go.
Yeah,
so that will be on the next
We'll
question.
leave that for Tom.
And the next question is, there is no real-time monitoring technology. How can we be sure of the efficacy of treatment systems when they seem to be working, but actually they're not? And Marcy might introduce some other work we've been doing, I guess, on that area.
Yeah, so in my view, primarily the way to first ensure that the system is working is that its operational parameters are working and functioning as they have been type approved tested. The type approval testing is extremely arduous and detailed, and they spend millions of dollars on the testing. So when we do the testing, we set what those operational parameters are for those treatment systems. And so if we can verify that proper functioning on board, that is, in my view, the first line of defense. And then we can now get into like indicative analysis testing that either crew members or port state control members can utilize. And that's a whole nother topic of how do we basically do a quick check, but not spend, $70,000 US on a detailed biological analysis. Do you want to add anything? No?
And one last question, and I am also a self-confessed ballast water geek, so it makes me sad to ask this question, and isn't it just too late for the convention, is the question.
You want to take that? I don't think so.
I think the answer is no, and it certainly should have. It's quite frustrating that the convention was adopted in 2004, and now here we are 15 years on without it being implemented, or it's really just going to get implemented starting in September of this year. However, when you look at the invasive species increase, we're really still on the uprise. So all indications from biologists who study invasive species vectors are it's late, but the world's waters are far from mixed in terms of biology.
Okay, we will close the questions there. Thank you again, Kevin and Marcy.
All right.